11 million tons of agricultural chemicals are poured onto America's vast farmland every year. They quietly poison the waterways, drifting from the mighty Mississippi to the small creeks of the West. One can notice how the water loses its vitality, leaving life increasingly sparse and exhausted. But this is just the beginning. People tried something unprecedented by releasing a few beavers back into these places. Why trust a simple rodent to fix a complex industrial problem? At first glance, it seems unlikely to succeed without advanced technology, but the unexpected happened as the small natural engineer began to work. It is visible how they build without blueprints, funding, or construction permits. Using only teeth, mud, and branches, they erect structures capable of reshaping entire landscapes. Transition to the next level. Can this creature really pull an ecosystem back from the brink of collapse? The journey of revival begins here. 2 billion tons is the volume of waste humanity releases into the environment annually. Why do river systems that once supported civilizations face global decline? The water flows quietly in streams, seemingly unchanged. But hidden within the currents are nearly 50 million tons of plastic and over 100 million tons of industrial chemicals. These pollutants push the waterways toward degradation. But this is just the beginning. Nowhere is this process clearer than on the Mississippi, the nation's main artery. The river drains 40% of the United States, carrying the wastewater of 31 states. One can notice how the current delivers massive amounts of nitrogen and phosphorus into the Gulf of Mexico every summer. This chemical load triggers the creation of the infamous dead zone. According to NOAA data from 2023, this oxygen-starved area expanded to 3,058 square miles. This territory is comparable in size to the state of Delaware. Almost no bottom-dwelling creature can survive in these suffocating conditions. It gets more complex further on. More than a century of damming, channelizing, and draining wetlands has physically altered the landscape. At first glance, these engineering controls look stable, but in reality, they have stripped away nearly 50% of the upper Mississippi's floodplain forests. Meanwhile, the lower Mississippi has shrunk to only about 30% of its original extent. This once life-giving giant has effectively become a machine for producing floods. The disaster of 1927 caused damage equivalent to more than $25 billion today. It remains recorded as one of the most devastating natural catastrophes in American history. The water continues its course downstream. $893 billion is the estimated total economic damage caused by wildfires every year. This financial loss defines a period of severe natural catastrophes in American history. Rivers grow exhausted from pollution, while the earth heats up faster than ever before. Global temperatures are rising about 0.2 degrees per decade. But this is just the beginning. Why does this specific temperature shift threaten the entire ecosystem? The heat gradually dries out forests, making vegetation significantly more flammable. This fuels wildfires across the world with increasing intensity. One can notice how ash falls into rivers and streams from California to Canada. In the year 2023 alone, the United States saw more than 2,690,000 acres burned. Fertile soil is scorched away during these blazes. Water flows become more erratic than ever as the ground loses its absorption capacity. The process is only gaining momentum. At first glance, the weather patterns seem familiar, but in reality, climate change intensifies everything. Humidity drops and winds grow stronger, meaning a single spark can turn into a catastrophe within hours. Forests disappear, wetlands collapse, and rivers, already weakened, are pushed even closer to breaking. The danger persists without pause. 60 million, the number of North American beavers hunted from the 17th to the late 19th century. They were pursued relentlessly for their fur and castoreum until the species faced near extinction. By the early 1900s, many states held only a few hundred survivors scattered throughout remote wetlands. Why was this disappearance critical for the environment? It seemed like a simple loss of wildlife to the untrained eye. But ecologists in the mid-2000s realized that without them, streams dried up faster, wetlands vanished, and wildfires spread easily. In 2008, the Mathau Beaver Project began restoring populations across the North Cascades. Using humane traps and health checks, they relocate beavers from residential areas to degraded watersheds. One can notice how the animals are moved to places that desperately need water retention. But this is just the beginning. The massive wildfire of 2014 created a unique experiment. 8 pairs were released into 3 burned-out basins. They faced the challenge of survival in a destroyed habitat. At first glance, the valley seemed dead, but in reality, the beavers began transforming the land. 1 year later, all pairs had survived the winter, building more than 15 new dams. It is visible how the basins turned back into green, wet landscapes in just a few seasons. The ecosystem slowly heals without haste. $1.2 million was the allocated budget for a hydraulic dam project in the Czech Republic that stalled for 7 years due to paperwork. A single beaver colony intervened and built a dam in the exact location marked on the blueprints. The animals restored wetland conditions so perfectly that officials admitted the work was done for free. Why do ecologists call them ecosystem engineers? The title implies structural influence far beyond their size. Every bite and every branch a beaver carries home sets the stage for a scale of rebuilding no other animal can achieve. One can notice how the flow of restoration begins with the very logs held in a beaver's mouth. Their dams do not block water completely, but slow the velocity down significantly. The current spills sideways, soaks into the soil, and forms new wetlands across the terrain. At first glance, the debris looks random, but in reality, sediments trap nutrients within the structure. In just a few weeks, reeds take root, and willows and aspens sprout along the banks. Insects return in waves of renewal. But this is just the beginning. The ponds created become oases in dry landscapes where mule deer, moose, grouse, and mallards stop to rest. Small fish find refuge in the water, while insects flourish in the new habitat. Ecologists identify the beaver as a keystone species, a pillar that prevents the system from collapsing. Riverbanks stabilize naturally without the need for excavators or concrete. 300 beavers, exactly the number of natural engineers reintroduced into the upper Mathil River since 2008. Why trust the management of critical waterways to animals? It would seem easier to build concrete reservoirs using heavy industrial machinery. But without these creatures, reproducing the 176 ponds they built in a decade would cost humans millions of dollars. One can notice how the rhythm of renewal reaches deep into the very waterways of these drought-stricken valleys. Engineers recorded nearly 5 million gallons stored in the first 62 ponds alone. A single beaver dam holds approximately 1 million gallons of surface water. But this is just the beginning, because the total system now retains more than 65 million gallons of water annually, enough to supply a household in Twist for over 20 years. At first glance, the benefit seems limited to surface water, but in reality, it extends much deeper. A study in the Columbia River Basin confirmed that 29 ponds added 6.6 million gallons of groundwater. This reserve helps regions endure even the harshest droughts. It gets more complex further on. It is visible how the permeable structure of the dams allows water to seep directly into the soil to recharge aquifers. But streams without beavers often dry to bare rock by late season, while those with beavers still hold water. The stored liquid releases slowly during summer, keeping the flow cooler and steadier. Thus, life continues to persist. 3 times higher moisture levels define specific valleys in the dry regions compared to the surrounding terrain. Why do these areas survive while others burn? It is not a matter of random chance. The answer lies in beaver dams, which act as shields scientists never expected. Surveys in Washington and Idaho identify these valleys as fire-resistant oases in drought-cracked landscapes. But this is just the beginning. Researchers utilizing NASA satellite analysis from the year 2020 found that areas with dams retain 3 times more moisture than places without them. One can notice how this accumulated dampness significantly slows the spread of flames. It seems obvious that ponds stop fire, but in reality, the structures spread water to soak the soil deeply rather than just holding it. This preserves a cool layer of mud, creating damp depressions the fire cannot consume. The process is only gaining momentum. During the twist fire of 2015, many ponds were scorched on one side while the other remained green. It is visible how firefighters even used this accumulated water to battle the blaze. As a result, beaver ponds act as ecological fortresses in the midst of severe fire seasons. Thus, life persists behind the natural shield, 70 to 90%. That is the rate at which Chinook and coho salmon populations have declined in many watersheds. This collapse occurs in the midst of increasingly severe fire seasons, threatening the biological stability of the region. Washington is home to 7 native salmon species, but over the past 40 years, their numbers have plummeted. But this is just the beginning of the struggle. The resilient life surrounding beaver ponds leads to another story, one where an iconic fish is being pulled back from the brink. Why has the habitat degraded so drastically in recent decades? The state's human population grew by 63% from 1990 to 2020, causing floodplains to shrink rapidly. Puget Sound alone has lost more than 1/3 of its natural shoreline due to this expansion. Consequently, warming waters and streams squeezed by concrete have destroyed the environment required for survival. Hope has emerged, however, from these small engineers working within the Tulalip Beaver Project. Since 2014, the project has reintroduced more than 200 beavers into creeks in the northern Puget region. At first glance, the beaver seems like a simple rodent, but in reality, it acts as a complex hydrological manager. One can notice how the landscape shifts as they construct their barriers. The animals build long chains of cool ponds to reshape the water flow. Some systems feature 12 or 13 consecutive dams, slowing the current effectively. It is visible how the structures provide shade, lowering the temperature. Furthermore, the stagnant water produces swarms of insects that young salmon depend on for sustenance. Ecologists have documented hundreds of juvenile salmon returning to places once written off as dead streams. Thus, the ecosystem slowly regains its natural rhythm. 150 relocations in 2023 alone helped create dozens of new dam complexes in the state of Washington. Rivers previously written off as dead streams are returning to life, bringing back salmon and reshaping the way people view beavers. Why did the state choose a different path for creatures often pushed to the edge of extinction? At first glance, they seem like troublemakers that cut down trees, damage levees, and flood yards. But in reality, the state decided to turn those instincts into a force for natural recovery. Programs like the Methau Beaver Project and the Tulalip Beaver Initiative now function as specialized ecosystem reconstruction teams. They respond to every call about nuisance beavers to humanely trap each animal. One can notice how the specialists run thorough health checks before moving the beavers to depleted watersheds. In these remote wetlands, the animals are released to work where their skills are needed most, because in these zones, the instinct to build dams transforms into the most valuable resource. it is visible how the new structures slow down rushing streams, add shade, and lower water temperatures. This reopens lost migration corridors for juvenile salmon, which had survived only in small pockets. But this is just the beginning. One can observe how watersheds once written off as hopeless finally regain their first rhythms of life. Tens of millions of beavers vanished from North America due to a relentless demand for luxury. Why did a single pelt carry enough value to nearly erase an entire species? The answer lies not in the animal itself, but in the specific properties of its coat. For nearly 3 centuries, the ultrafine underfur served as Europe's most coveted material for felt hats, driving a hunting frenzy across the continent. But the journey of the pelt does not end with the hunt. Inside the tannery, each dried hide arrives like a rare commodity requiring immediate identification. Workers assign a unique code by punching tiny holes into the skin to ensure precise tracking for every supplier. One can notice how the stiff, dried hides are immediately submerged into a rehydration vat. A solution of salt water and specialized chemicals restores the original moisture over a period of more than 12 hours. At first glance, this soaking seems like a simple wash, but in reality, it is the foundation for transforming raw hide into durable material. From these freshly rehydrated pelts, the process moves to a stage demanding absolute precision. The hides are bent over a wooden beam or fed into a specialized machine to soften each fiber. This mechanical action opens the structure of the dermis, allowing the leather to breathe again. But this is just the beginning, because without this opening, the treatment solutions will not penetrate deeply enough to preserve the material. The tanner begins flushing the hide, shaving off the first thick layer of tissue to create a surface accurate to the millimeter. Immediately after, the pelt enters a second soaking bath containing a carefully calibrated degreasing solution. This chemical mixture must be strong enough to remove all natural oils without damaging the delicate hair follicles. Any residual fat left behind would eventually cause the leather to rot or discolor. Once lifted from the vat, the hide undergoes a second fleshing to thin out dense areas like the shoulders and tail. This critical step defines the softness and flawless coloration of the finished leather. It gets more complex further on. The material enters the most delicate stage to create sheared beaver by removing the guard hairs. The tanner immerses the pelt in a formula that loosens only the guard hair roots without touching the ultrafine underfur beneath. It is visible how workers place the hide over a beam to carefully scrape out each guard and juvenile hair. One wrong motion or broken hair instantly turns the pelt into a worthless reject, costing the tannery several $1,000s. Precision clears the way for the final structural changes. A pickle solution tightens the grain and locks the underfur roots in place before the hide is shaved again to the exact thickness. Workers move the material into the wet tanning phase to stabilize the fibers. Inside the rotating drum, powerful cycles break up stiffness to create the signature drape. The hide is stretched to open the grain, preparing it to receive a layer of tanning oil. Specialized pounding machines press the oil deep into the fiber, restoring natural flexibility and sheen. For sheared orders, trimmers guide the pelt through precision blades to adjust the length of the fur. Finally, the hide is bleached, cleaned, and tumbled for hours to achieve the necessary luster. The processed material is now fully prepared for the fashion workshop. Zero imperfections define the smoothness and luster needed before the material moves on to the fashion workshop. Amid humble dams and newly revived streams, beavers stand as proof that nature still holds wonders we have never fully understood. But this is just the beginning. Why is their impact so profound? At first glance, they are simply building shelters from timber. But in reality, they don't just restore fading waterways. They awaken entire ecosystems long thought forgotten. Every bite they take and every surge of water they redirect brings new life to the area. One can notice how birds return to the wetlands, while fish find shelter in the ponds. Vegetation rises again after years of drought. It is hard to believe that such a small creature can reshape the fate of an entire landscape.